All right, guys, this is Mr. Hayden again. This is Chemistry Week 15, Chemistry Week 15. So this is what we're going to be doing. On people on the internet, we're going to be going over electroplating, the concept of electroplating, why it is, and all that stuff. Different parts of electroplating, like the different names of the parts of when you set up the actual project. I'm going to jump into the virtual lab, kind of show you how to set it up, and then so you can do your observations. And then I'm going to cut you guys loose to go ahead and turn in the assessor questions so you can do your lab if you choose to do so today. The people that are in person, we're going to go ahead and set up the lab in person here. We're going to talk about it again and how to set it up, and we're going to load you for real quick. And then the people who came in today are going to get credit because we're going to talk about observations, and we're going to be observing it a little bit. And then yeah. That's it. So there's going to be two steps. People in here will be a little longer than people online, but they're also going to be getting credit for coming in person, and their grades are getting awesome. So let's get going. Awesome sauce is better than not awesome sauce. Not awesome sauce. Oh no, sorry, my beard got in the way. All right. Some things to go over. There's about 5 weeks, 5 weeks at the store, so. So the end of this semester is kind of coming up pretty quick. So if your grade sucks, if it's not that good, and you want to bring it up, this is probably a good time to do it. You're literally need to finish the race strong, better start running if your grades aren't very good. Your science notebook will be due basically starting in 2 weeks. Okay. May 11th through May 22nd, there's a 2-week period. You can come in and drop it off, or not drop it off, but show it to me. I recommend not dropping off because you can use it on your final. And also I recommend not stopping it. Again, once I grade it, it's done. Like I don't have to see it again. The grade is the grade you get. But if you don't continue it on, then you won't have the information for it. And that's it. What you may need. So at that point, it's kind of on you to finish that. So again, starting May 11th to May 22nd. So like example today, today was May 12th or whatever it is. Because I think that's a Tuesday. Then after you have all your science notebook here, you go, it's ready, you're ready, you can be awesome. And then you basically, at the end, I'll start going through and quickly filling it out and grading right here. As soon as I grade it, give you a score, and then you piece out, and we're done. So, and if for whatever reason you don't have it that week, then guess what? You have a few more days to do it. If you don't get it to me by the 22nd, then you lose the point. Sorry, Charlie. I think a 2-week period is easily enough. Also, again, please make sure that your grade is where you want it to be. And if you do not have a grade that you found if you look at your grade and you don't like it, you get like depressed about it, then it's obviously not the where you want it to be. If you look at your grade and go, yeah, that's about right, then you maintain that. If you look at your grade and say, yeah, I'm so happy, look at the A, then you can't get hired. Agreed? People look already confused about the fact there's not a higher grade than an A.
Well, if it's a D or an F, and you go, yeah, that's about right.
Okay, here's a rule of thumb. If it's an F, don't do that. yeah, 20%. Yeah, that's about right. Not. And by the way, everyone's grades count. Because I zeroed out what was supposed to be zeroed out. I zeroed it out last week, but for some reason the system didn't update it. So everyone had basically a D or higher. And then I'm like, oh, it didn't read what I zeroed out last week. So I zeroed out what it was supposed to be. So your grade drop was because it was supposed to be, which I did, but the system didn't recognize it. That's my bad. So blame the system. Easier blame the system? But and you don't know myself. That's the American way. That's the American way. So was it me? No, anyone else. It was everyone and anyone else. It was Mickey. Mickey made me do it. Mickey of the mouse. Okay, so the essential ideas, the essential question for the people online is I want you to describe how to electroplate an object, and then also be able to decide which electrolyte and which an anode and cathode to use. And again, this will make more sense when we get into what the heck those even mean. Because some people are like, I don't know. Some people get it, so we'll see what's up. So again, electroplating. By the way, the description is not a cut, copy, and paste. It is your own words. Please. You don't, everyone done writing it down? Let me just give me a weird face if you're done writing it down. Perfect one. Speaking of home runs, yeah. Maybe a 50-year-old, I think. Homeroom kids, I guess 50-year-olds will turn in your stuff. All right. So it's like, why do we need this? Like, if we can do it, but why? Like, it's like, oh, cool, I can do this. Yay! Why? Like, there's a steel can. Why do I need to code it? Huh? No, you're not in class. So true, go ahead. Nope.
Reinforce it?
Now, the question was, why would you do it? And the answer was to reinforce, to make it stronger. But there's literally such a small layer of actual plating that gets put on it, it doesn't really structurally do anything. It's just coating. It's putting like a layer of a couple like atoms enough to cover it, just to basically change the way it looks. Like, there's a bunch of people late, so they do. I don't know about it. So the question is again, why would you do this? Why would you take something and code it? Well, in the case like a steel can went out. Well, what happens if like a steel can isn't coated? What could happen to it? Say it louder. Like people thought it. Their brains all went rust. Okay, oxidation. They would rust. Now, but how many cans of soup would you want to buy that has rust all over it? At least 4. I can buy them soup on sale. Okay, if you have a coupon, buy 4. It's this can free rust. Oh yeah.
It was free, and I just take it.
I don't care. It's rust. It's killing me. I don't care. I'll leave it. But no, it's like why would you? If you could protect. So, example, like out on your car, there's bumpers. Does anyone have any chrome bumpers? Chrome rims? I wish I chromed my car, man. Alright, well, back when I was young, I'm young now, but younger, and I was your age, the big cool thing was like chrome rims, chrome this, chrome that, bellows exhaust, all this stuff. And what it is basically a piece of metal that's dipped in the solution to have chrome put onto it. And just protects it, makes sure it doesn't rust, it's shiny, whatever. But that's what it is. It's a protective layer to change the way it looks. Sometimes jewelry is a certain substance, whatever it is, and then they coat it with like gold on the outside. And it's not gold. It just looks like gold. There's not even enough gold really on it to get any value out of it. It's just there. But that's what people do. They coat it. Could you imagine if like you knew what this was back in the day? Like way back in the day when it was like the gold rush time? You're off just randomly coating like different types of metal rocks with gold. You're like, it's gold! And until someone finds out you did it and shoots you on fire. Besides that, they figured that out real quick, by the way, just by they bite into it. You guys know that, right? They bite into the gold.
You just scrape it or something?
No, the gold is so malleable that you can actually put indentures keeping good if it's 100% pure 24 karat gold. With there's no other stuff put in it. Because other metals you put in make it like hard. That's why rings are like 14 karat gold and 16 karat gold.
Isn't it gold with the softest metal?
It's pretty soft.
So why do people?
Mercury, a pretty soft metal, like so soft. It's liquid. It's softer. Leather. It's cheating. All right. Question? Go ahead, Adam.
Oh, that was saying, why do people buy normal coins then?
By normal coins?
Yeah, in cartoons and movies and shows, you always see people take money from someone and then they bite the coin.
The idea of the coin is theoretically gold. There's a different color that is completely a misnomer altogether. That's why they bite into it. There's also like old things because like people used to like shave just a little bit off. Like there was like a whole bunch of shady people back in the day. They came up with like weights and all this stuff to make sure it worked. It's one reason coins came along, is because people are shady, basically. You need an equal amount of something to trade. Okay, so right here, this is a nickel plating apparatus.
So here's a way to look at what it actually is.
You guys watch The Simpsons, right? It's like that old. It's still off, right? All right. So electroplate is used to coat one metal onto another metal to look better or prevent corrosion. And then looking better is all subjective. So the kappa must be the object you are plating. So that is the one that is getting the substance put onto it. It's the one being coated. It's the ugly one. Let's just talk about it. It's the ugly one. We're going to talk about the pretty one now. Okay, and then there's the anode, which is the metal you are using to whatever. Must be the metal. I didn't write it. Alright, so must be the one. So the anode is like gold or whatever you're doing, the chrome, the chromium, or chromium, whatever it is, the actual element name. So again, those are important actual definitions to know. And it depends on which we're going. Okay, and the electrolyte is going to be the solution. And the solution is going to actually going to contain the metal that you want to put on there. So it's like example, this right here is copper sulfate. There's copper, so this will actually help with the removal of other copper ions, build a plate onto something else. And in this case, these quarter blades on it. Oh, found it. Don't freak out. I found it. I saw you freaking out. Alright, so we good? And by the way, what this on the right-hand side is, that little line with the dark little box next to it, line in the dark box. For people who don't know like physics, that's the way to put some sort of a electronic battery or a cell. That's what that is, okay? It's just basically the battery or some sort of an electron mover in some cases. Could be AC or DC current. Positive charge, negative charge, those are the terminals. And then that little view thing, that is a glass, and then the solution's inside of it. So in this case, we have the nickel sulfate. So it looks like we have nickel, a nickel anode, and then we have a nickel sulfate solution, and they're trying to coat the copper. Got it? Got it good? Okay, so here's another kind of like picture. It's just, what happens is not enough to really completely destroy the metal. They will kind of discolor it sometimes because literally you're pulling off atoms. Like literally you're jumping off into the solution and I'm gonna go hang out over here, and then they're like kind of electronically being like pulled over here and like grabbing a hold of the new metal and just like I'm gonna hang out and make this thing pretty enough. And that's what it does. Because everyone knows gold is pretty, right? If you does not think gold is pretty, then bring me all your gold in your house. Are we good? We're good at it, right? It's ugly. I'll give you lead. Some lead. Some lead.
Can I put it in my pocket?
Yeah, long periods of time, and then let your skin absorb it, and you'll be fine. Except for the lead poisoning. I'll just explain it. The tin is tin, not tin. Tin is better. Oh, maybe. Well, gold is used more.
Well, let's give it readings.
Yeah, like my phone working.
Yeah.
There's gold in here.
No.
There's actually people who like take like stuff like this because there's gold inside of here. Like there's gold stuff. Not a lot, but there's gold. And they'll like take all of it and they'll put it in solutions and they'll like all like have it just like they'll take off the ions and they'll like absorb it onto something else so you get gold out of it. They take gold off the stuff. People do that. It's a thing. What after it's done, like old computers that like basically don't work anymore, you can theoretically pull gold off of it by using the electroplating process. Bye. Enjoy your day. All right. Oxidation is the loss of electrons. Reduction is the gain of it. So here's just a quick little, like, it's called oil rig. It's kind of like that Sacagawea and whatever it is, or what is it? Sacagawea, whatever. They're all the same. Not even close to the same, but whatever. It's like an acronym to help you remember things. So oxidation is loss, oil, reduction is gain, rig, oil rig. Like you say it with an accent, you're like, it's oil rig! I can do that. That I can use the accent and do the whole period that I cannot stop.
So you probably shouldn't start. Should start just in case.
Just in case. Oh. I remember one time I did a whole class like that. It's like a, I don't know if I did it here, but I know for a fact that I taught elementary kids for like a period when I did expulsion school. And not elementary, middle school. And same. Oh, I just walked in, it was just from start to end. They're like, what are you doing? They made them pay attention. Because they're like, what are you doing? Why are you? And they're like, they're still learning, but they're like paying attention to my words and laughing at me. Because of the accent. That's why they're laughing at me, because of the accent. Coding still with tin. So again, coding the steel with tin. There you go. Look at that. Vote for the tin, man. Coding steel with zinc. With zinc. Coding a steel coin with copper.
I like how you started dancing and doing the team job. That was weird.
Alright. Okay, so again, here's oil reg, same, oxidation loss, reductions gain. Alright. And then now, I'm going to just quickly step back behind the questions because I want to be able to show you. I want to show you the, I think this is it right here, right? Blackboard. Nope. Let's go back. Just kidding. Stop sharing. Give me a second here. This happened last time. Oh, good. I'm glad that it just went away for no reason. There it is. All right, so I want that. Start sharing. Okay. Is it working now? Okay, I'm pretty sure that's working. If not, then you should show up live. All right, so this is what we're going to do. I'm going to show you how to set up the lab so the people on the internet could get that done later. And then I'm going to go ahead and cut you loose so you can go turn in the information you need to meet. And then we're going to get going here in class with the lab here. So, and by the way, some of the stuff here I will go over is going to kind of also speak to this. So pay attention because this basically is this. It's this in person. All right, first of all, you have your timer. You have your glove. Mine's blue. Don't be jealous. And then you also have the solution here. Okay, the solution is probably a copper sulfate if I was to just take a guess. It is blue and we're working with copper, so that's probably what it is. We have a 6-volt battery. Sometimes you can use the D batteries, the D-size DCs, and you can put two together to create the same amount of current. I have a steel wool here. I wonder if you'll have me do it. All right, steel wool, and then also magnifying, or what is this? Yeah, magnifying glass, so I can zoom in. It's kind of cool. All right, so what we're going to be doing is setting up the lab. First, you have to create a circuit. If you have not made a circuit before, you need to basically attach in a circle so the electrons can make a round completely through a full cycle. If anything's broken, it doesn't work. Right now in this room, not on the internet, the lights are off. Right now there is a wire going from, wherever, power source, all the way to this switch. The switch is going through the lights, all the way back through, and then back to the lights. And what happens is when I flip it on, it's a piece of metal goes in between and it allows for current to pass through it. That's what an on switch is. When you turn it off, all it does is it breaks the circuit, does not allow electrons to pass through it, and it goes off. So we're going to make a circle. All right. So first of all, I need to actually clean the coin. So it says to, just so you know, it says to pick it up and hold it over it, and then hold your button down, and it will clean it amazingly. That's just really cool. I got really annoyed when I finally had to watch the tutorial and it showed me how to do that. And by the way, you can always watch this tutorial and I'll show you the same thing. Same thing? Did you hear it? It's actually here as it goes cleaning it. The reason why I'm using steel wool to clean both the coin and the copper is that if there's any type of oxidation on it or any type of oil or any type of fingerprints, anything on there, it won't work. It needs to have the metal being completely bare to the solution for it to work. And then I'm going to go ahead and take my, I don't think it really matters which. Maybe it does. Don't you love it? Come on. I'm trying. Ha ha ha! In the face. I don't want to hear it, Destiny. Ah, in your face. Okay, what I did, just so you know, is I put the coin, which is clean, into the solution so it's partially or fully covered. And then I'm going to take this and then hook it to the negative side of there. Black typically means negative charge in talk about circuits. Now what I'm going to do is I'm going to hook in your face. And now I have the positive charge, and I'm going to pick it up. I'm also going to put it in the other side. Now, I'm going to hook now this little bad boy to the positive side. Boom. As of right now, there is a current going through it. So what we do is we start the timer, and I believe it's 10 minutes. I think as the lab says we're going to be doing this. And then over time, you're going to sit there and observe it. What you're going to see is, you zoom in. Now, it may not look like I created a circuit, right? Because there's no wire connecting the copper to the coin. That's what the solution does. The solution is making basically the copper jump off. I just jumped in person, so my feet hurt now. And then if you guys felt the earthquake, let me know. And then the solution actually goes over and coats the coin. And so it's making its way, right now the electricity goes here, and then now pushing it over to here, it's combining on here, and then the electrons are moving this way. The negative electrons are moving back through the wire the other direction, which is leaving a charge for the positive charge ions of the solution to attach to it. And it'll continually happen like that. Usually it takes about 30 minutes or so to get this charge. The way to agitate it, we learned before, is I would go stir it in there, because what I'm doing is I'm allowing more molecules to slam into it, and it'll actually work that way. And so what we do is we wait around here for about 10, 15, 30 minutes, whatever it is, and we just stare at this. There's a reason why I'm fast forwarding this and kind of cutting these people off to go do it. Now, the next thing you want to do is after you're done, whenever you stop it, you're going to observe what you see here. All right, so I'm doing this, and then I go over here. Here, pick it up. And I can observe. Do you guys see that? See how it looks darker on one side and say lighter on the other? Okay, it's just basically being coated. Not a big deal. You're going to do the same thing with the coin right here. You see there's a coin. And then you're going to write both of those down so you can get the virtual lab completed. Yes, you can coat coin. The key! All right, I'm thinking of the coin still. I like money. But there's also a key. Sorry. She's looking at me like, why didn't you just say a coin? You're an idiot. I was like, okay, I'm an idiot. No laughing when I say idiot. My homeroom kids are cracking up. Everyone else was quiet. That's it. Truancy. Truancy for all of you. All right, so I'm going to go ahead and get rid of this. I'm going to stop the sharing. Go back to the original. So if you have any questions, make sure you ask them. Isaac, if you want to go ahead and peace out, go ahead and complete that lab on your own. Make sure you submit that for grade in the actual lab portion, and then make sure you also then turn in the essential question in the Dropbox for the live session to get credit. So there's two things you have to do. Turn it into the actual lab basket as well as do the other one. All right, we good? Have a good rest of your day, and take care.